Hello and welcome to Advent of Code in F# Day 7. Let's dive straight into it today. Handy haversacks? That's a word I don't know. We land, yeah, in fact it looks like we'll even have time to grab some food. All flights are delayed because there's issues in luggage processing, the struggles of air travel. Due to recent regulations, our puzzle input is rules. We're being enforced. Bags must be color coded, yeah. And must contain specific quantities of other color coded bags. Okay. Light red bags contain one bright white bag, two muted yellow bags. Okay, so there's like bags containing other bags in colors, numbers of bags. Sometimes they don't contain any other bags. Okay. We have 9 bag types. An example, okay. We have a shiny gold bag, of course. It's my favorite kind of bag. We wanted to carry in at least one other bag. How many different bag colors would be valid for the outermost bag? How many colors can eventually contain at least one shiny gold bag? Oh yeah, so we want to wrap the shiny gold bag into another bag. And how many options do we have? Okay, this is a more interesting puzzle today. Bright white bag which can hold your shiny bag. So we have rules that apply directly to the shiny gold bag. Let's look it up. Bright white, one shiny gold, yeah. So some rules apply directly and other rules apply recursively. So if you have a bag that can hold a bag that in turn can hold a shiny gold bag, we're also good. Okay. So we need to look for different kinds of bag that can eventually contain at least one shiny gold bag. So basically it's saying find all the different bags, not even the different rules. Is there one rule per bag? Yes, there's one rule per bag, so we need to find all the rules that directly or recursively allow us to carry or hold a shiny gold bag. The list of rules is quite long, make sure you get all of it. Uh-oh. Oh dear. This is not a puzzle you do by hand, or I won't be doing this puzzle by hand at least. "600 rules, give or take." Just gonna do some quick searches. Yeah, probably one rule per bag type. Otherwise we'll see soon enough. So strategy, what are we gonna do? The easy part will be parsing these rules, but then we know we need to hold a shiny gold bag. So if we work backwards, like do a breadth first search or whatever, do a backward search from all the rules that allow you to hold a shiny gold one, then we can build a list of bags that can hold shiny gold. Yeah, sounds reasonable enough. We are going to have to parse the rules, like the bag it applies to and a list of bags and number of bags it can contain. For the past for every other exercise where we had to parse some text, we used the regex provider. But I'm thinking today I'm gonna play around with something else. It's called active patterns. Let's see if we can get it working. What's a good example? There's a one bag, multiple bags. I think the first one is a good example. No, let's parse one of the test rules maybe. It makes no difference. Let's do one. Yeah, let's take this one for example. Let's wake up the REPL. There we go. Yeah. So let's parse this. But first I'm gonna just use a regular expression. Okay, my keyboard decided to switch language. That's there. Man. Do you really? It's complaining about me dotting into a new object, yeah? Okay. Just trying to get this to work. Okay, so now we have the structure in place. Let's noodle about the rule structure. Is it always blub blub bags? Blub blub bags? Yes, it is. So here we have some. I won't even try to do this without some visual feedback loop. Regexer. This is not where this goes. This is where this goes. So. Yeah, and then a couple of digits, and then a couple of characters for the type of bag, and then it's bag, and then it's a comma separated list. It's a comma separated list. Are we going to do this with a single regular expression, or are we going to do some string splitting? I wanted to show you active patterns in F# today, so the best example would be to string split actually. So everything except everything after this part, let's parse that in code, not with a regular expression. So we have the rule, or the bag, the rule is about, blah blah blah, and then a comma separated list of bags this specific bag can contain. You can do it in a single regular expression, but I wanted to show something today, and it'll be better if it's a bit more code than just a single regular expression. So, yep. How do you get the things out? Is it first? I think the first one group is always the entire string. No, I did not define any groups. Is that the problem? I should have matched beginning and end. I didn't define any groups. That's also a problem. So is there no way to get it out just as is? It's not in groups. Is it in? Does it have something else? Captures maybe. So yeah, that's what I was talking about. First one is always the entire string, and then both. There's nothing else in there. What's it called? How do you do this? Groups or captures? I'm quite sure it's one of these twos. It's only one capture. It's only one group. Interesting. Let's extract. Let's extract them into a group name that we've been doing for the entire advent code. That works. So let's stick with it. What was the syntax again? This? No, it's not really matching anymore because there's a bit too much. There we go. Yeah, that's the syntax. And these are the rules. Let's not pull in the dot at the end. So we have bag, which is the rule, the bag the rule is about, and rules is a comma separated list of all the rules. That looks like something we can use. And I'm hoping now we can do groups. Is it like an indexer? Yeah. This should give me light red. Is that the one? Yep. So let's extract that. And let's extract the right hand side of the rule. So it's a comma separated list. Let's rules underneath the value. That's a comma separated list. It's a string, so let's split it comma space. Yeah. Oh yeah, and actually we need to parse the number of bags out of there. And the bag or bags can go as well. Maybe it wasn't that smart to not do it in a single regex. No, let's keep going. I wanted to make a point and I'm damn well going to make it. So rule strings is a bad name, already disliking it, but that's as far as I'm going to get this morning. Let's parse the rule strings. Not liking what I'm going to do, but hey. A car array. Let's split on space. Work our way back from there. Why you no likey? No overloads. It needs to be an array, not a list. So we have our rule strings. Let's map over a split by space. Whoa, that took a long time. Okay, was a fluke. So first one is the number, which we will be ignoring for now, I think. The numbers are not relevant yet, but I smell a part 2 coming up. So let's keep them in the parsed results, just to be sure. Do we need a type? No, we don't need a type. Let's keep it in a pair. So what we need is, let's not keep it in a variable, let's just keep on mapping. So now we have our list of strings. Oh, you know what, I'm not gonna go fancy composition things. So this is the array, and we need to, you know what, I'm gonna extract this in a small teeny tiny helper function. Yep, let's do it this way. And hopefully this time it works, yeah. Ever since my Visual Studio crashed when I did a refactor, I'm doing it by hand, but it's a bit slower. Interesting. Do you have something for me? Yes, we do. Okay. And let's return the number, but ignore it for now, which is always the first word. And all the rest should be everything except the last one. So words to yeah, let's just take everything and skip last. Can you do something like that? No. Okay, then let's do it until words. And it always trips me up. -1 minus. If we have 3 words, we need to grab only 1. Is it -2? Let's try it out. And we have some parentheses. We don't want, there we go. So this should parse a string into a list of tuples. Yes, it does. And it's 1 bright white and 2 muted yellow. That looks correct. And let's zip those strings up again. It's not the most efficient way of parsing the input, but it fits the point I was going to make perfectly. 1 bright white, 2 muted yellow. There we go. Let's maybe keep that space in there because we are going to reference these colors. There we go. Let's write a function called let's parse rule, and that's what everything we've been doing here. Where do we use example? There we go. Yeah, let's record whatever we did in a test here. Sorry, I haven't thought about my return string. So what are we returning right now? Not much. We need to return the bag and all the rule strings, right? So for light red, we can contain 1 bright white and 2 muted yellow. That looks correct. So something like this. It's a sequence, not a list. Let's just sequence it up. Row strings is an array already. Can I do a list map on an array? Probably not. No, you cannot. There we go. So this should be what we're expecting, right? Oh dear. Yeah. Like red, blah blah blah. Yeah. Let's paste this in. There we go. So we can parse our rules right now. Visual Studio is having a tough time today. There we go. I'm gonna move this closer to the tests. Let's parse the input now. Yeah, that looks good. I'm thinking the thing I wanted to show, active patterns, will not have that much use. So never mind. We're moving on. We parsed our rules and now we need to find how many bag colors can eventually contain at least 1 shiny gold. So let's look for the rules that apply to shiny gold directly, and then we have a set of bags that can contain bright gold. These are part of the answer, but we need to do this recursively until we reach a fixed point, so until we find no rules that match. Yeah, so I'm gonna call this the book of rules, the rule book. I don't know if you can see it behind me. Yeah, over there. Those are board games, so I know a thing or two about rule books. But anyhow, so let's find all the rules that apply to shiny gold bags. And when we say apply to, let's just write a function. You know what? I'm also going to put a type alias for the thing we have here. It's a sequence of string and then string list. Yeah, sure. Let's make a type alias. Is this how you do a type alias? Yes, you do. It's that's not what I was expecting actually. It's not a sequence. Sorry, these are all the rules. So this is the type signature for the rule book, but it's more like this. So this is what the rule is about, and then you have a list of tuples saying this many other, yeah, that's correct. And this returns a rule. Let's make that explicit. Yeah, at least now when the types don't line up, we can start to make a bit more sense of it. Okay, let's find all the rules that directly apply to shiny gold. What's the correct phrasing for shiny gold? Literally shiny gold. Okay. So, rulebook. Well, let's define a function applies, let applies back and a rule. Ugh, there you go. Keep mixing up my sequences and my list today. Okay. So this is a function we can use, or we can write to check whether a rule applies to a given bag. And this means that the bag is somewhere in the right hand side of the rule, like the list of ints and strings. So this means that the right hand side of the rule, my heart is aching for this not defining our types, but let's go with it for today. So this is a list of rules. And let's remove the number. Yeah, sure. Something like this. So take all the right hand parts of the rule, remove the numbers, and check whether bag is in there. Yeah, why not? Error input was what? What are you saying? There we go. There's something fishy going on with the when I run this line in the REPL, it doesn't like it. And when I run it with some context, it seems to not have a problem with it. Or is it? What's happening? Oh, it's going crazy. Have I written an infinite loop? I don't think so. No, I'm not doing anything recursively. Ah, we're not evaluating yet. Okay, yeah. This is why sequence can be dangerous. I'm gonna work with lists. I've had enough surprises for today. There we go. I'm just gonna throw everything away, rerun it. If the REPL feels like it. Hello, hello. What are we doing? Dear God, what's happening? Interesting. String to number. Ah, we're parsing the number somewhere. Where was it? Well, int words here. We're parsing it, and it appears that we're not thinking of an edge case or something, because it's blowing up. When all else fails, start printing. We have string interpolation now, but it's not in my fingers yet, so I'm just gonna dump the words and see where this breaks. Yeah, so we have a problem when building the rulebook. No, oh my God, are you kidding me? So there's not 0 in there, there's no. That's interesting. That's interesting. We are splitting on comma, so rule strings has the separate ones, and if we do parse right hand is a very bad name because we're doing only part of the right hand, but okay. So this can contain no other. And if it's no other, we can just return. Interesting. So then it's actually nothing. I'm thinking, should we have done an option? Yeah, we should have done an option. So let's do this retroactively. So if, sorry. So if we get the no other bags thing, then we say nope. And otherwise, we say sure. Here are your words, kind requester. And then instead of mapping, we can do sec.choose, and this will only keep, so this works the same as a map, but it expects a function that returns an option, and it ignores the cases where there's none, and it unwraps the cases where there's some. So this is exactly what we need. Let's see if we can parse the input right now. That's better. Yeah, I think we're good again. We are good again. The test is still working. Okay. So this is the set of rules that apply directly to gold bag. So in every rule we see here, we should see shiny gold. Shiny gold, yeah, that looks correct. But now we need to do this recursively. Yeah, now we need to do this recursively. And when do we know how to stop? We know how to stop when there's no more. So we're looking up rules that apply to shiny gold. And then we get several rules. So we get several bags actually, or rules for bags that can contain the requested bag. And then we do the same recursively for every left-hand side of a rule. And this will give us a list of options again. And we keep going and we keep going. So for this, we only need the left-hand side. So let's call that let's only keep the left-hand side. So these are all the bags that can contain shiny gold directly, and then we recursively call this. Yeah, let's write a function. I'm gonna call it find bags that can contain. There we go. I'm still having trouble figuring out the stop condition in my head, so we look up all the rules that apply. Let's pattern match on that. If we find no rules, we're done. Otherwise, we find some rules. Then we need to return the rules and recursively tail recursion, maybe if we hit performance problems, but I'm not going to worry too much about it. And find bags that apply for every rule. Is again a let's call this container bags. So all these bags can contain the requested bag. And let's, yeah, bags, and let's collect. So that's a map and a flatten at the same time. Let's collect all the bags that can in turn contain the recursive bag. So I think this might work actually. So let's find bags that can contain shiny gold. And let's count them up. We have 54. Is 54 the answer we are looking for? No. Okay, so as I think is the first time, let's take a couple steps back. How can we troubleshoot this better? By taking the example and walking through it. So in the following rules, let's first take a good hard and long look at what we're doing. Find bags that can contain the bag. So these are the bags that can directly contain the bag. And if we don't find any bag, we're done. If we find some bags, we say, okay, these are bags that can contain the requested, yeah. And now find bags that can contain single bag. No. Yeah, I'm not seeing it. Let's work through the example. Let's inline this here. And let's grab this. I should have wrapped everything in a function, but let's do that later in a cleanup phase that will never happen today. There we go. Let's just run our code on the example quickly. Oh yeah. Can we just split on new line character? All these programmer keys on my keyboard, I still have trouble finding them. This looks like correct split. Let's build a rulebook. Dotted black, no other bags. Bright white can contain. Yeah, light red can contain 1 bright white, 2 muted yellow. That looks correct. So let's run our piece of code on the input, and indeed it's not correct. So we should be finding 4 when actually we're finding 2. I'm thinking we have got our recursive call mixed up somehow. So let's do some debug driven development. Yeah, let's just print out the bags we find every loop. Name is not correct, but we'll inline that again in a second. Okay. So first we should find the rules that directly apply, which is bright white and muted yellow. That's correct, so that's first. And then we should be looking at dark orange and light red. Light red and dark orange, so that's also correct. And then we find nothing. That's I'm not sure what's happening here. So these are correct. Bright white and muted yellow. And then we find rules that can contain these bags in turn, yeah? And when we look up light red and dark orange, we're not having any rules match. So why is it doing it again? Why is there a... can we have multiple? Do we need to remove duplicates somewhere? Or in theory, bags can contain duplicates as well. Yeah, it can. So let's not overload with too many lookups, but that's not the actual problem. Actually, that didn't fix anything. You still see this. So what's happening? Let's step over it. Okay, I need to see this happen one last time. Okay, let's troubleshoot. So the first call to the function, we have those two, yeah? Bright white, duck, and muted yellow, yeah? And then we look up bright white probably, and it's saying, yeah, you have a hit here, and you have a hit here. And then we recursively do light red and dark orange, yeah? And then we work for muted yellow, which also gives light red and dark orange. So it looks like our looping is going correctly. What I'm seeing in my printout is what I need. It's in building the result that something's missing. So I'm building the result. If we find bags that contain dark orange, oh my god. If you look at the return type, it's not a list of strings, it's a list of strings. So again, I suck. Okay, this is better. So I was appending a list to a list that doesn't result into a list. This is a list append operator that like smushes two lists together into a single list. That's way better, and it took me way too long to find this problem, but there we go. Let's rip that out again so it makes sense. There we go. And let's not work on the example, but on the input. Whew, this is a different number. Jeez, thank you. That was part 1. Part 2. The struggle was real today. Okay, let's look at part 2. It's getting pretty expensive to fly. Because of the ridiculous number of bags we need to buy, you are correct. So consider again shiny golds. Faded blue bags contain 0 other bags. Yeah. Vibrant plum bags contain 11 other bags. What does the rule about vibrant plum say? 5, 6. Okay, so now we're working in the other direction. So a single shiny gold bag must contain one dark olive and 2 vibrant plums. And then recursively see what's in there. Yep. So shiny gold contains 32 bags. Yep. So we're going to go really deep. Yep. How many bags does our shiny gold bag contain? So if our top level bag is shiny gold, how many bags actually are in there? Now we need the numbers. I'm glad I kept them. We don't need to go in the right to left direction. We need to go in the other direction now. Okay. So actually we need to apply every rule. We start with shiny gold, we apply the rule for shiny gold, and then we get the right hand sides, and we do this recursively until they contain no other bags. So the rule book stays the same. Let's find the rule for shiny gold. This is not how it works, yo. Let's find a rule where the left hand is shiny gold. And then we have the bags it contains. These are the bags that are in there, yeah. Let's do the same as we did. Yeah, let's do the same. If we hit nothing, we contain no bags, and if we hit some, it feels like there's a... We don't have to use pattern matching, I'm guessing. Whenever I do this kind of pattern matching with, for example, options, there are functions out there that can do the same thing for you. But let's not worry about that. Let's first make it work. Ooh. Yeah, so these are in string lists. So yeah, this is one pair. And then we need to multiply the number of bags. Or, yeah, so it's 4 plus whatever's in this bright lavender bag times 4. Yeah, so bags is a list, so a number and a bag name, and we should return let's just do one step right now. So these are the right hand sides of the rule, and we say just map over them, and it's let's sum up the directs, but then we need to recursively dive into it. Multiply by, oh, it'll not be that bad. So let's write a function we can recursively call. And it's the number of bags in bag. If we find no bags, or if it's a bag that can contain no other bags, we're done. Otherwise, we look up, we apply every rule recursively, so that's what we have to do. So it's 4 bags plus whatever's in there, and that is 4 times whatever we calculate for that bag. Yeah. Shiny gold. If this is the first time right, I would be mildly surprised myself, actually. But we're lucky. We were not that lucky in part 1, but we were very lucky in part 2. So in theory, we solved the puzzle. In practice, oh dear god, I was stumbling along. So let's recap a bit. We used the regular expression to parse part of the rules, and then we started doing crazy stuff. Didn't use a record or structured type. We just like put everything in tuples and in lists. Struggled a whole lot with the list.append versus the concat operators. And we were using recursive functions. Where we could have used something else, I think. I'll think a bit about it today, and if I find a more elegant solution, I'll let you know tomorrow. But this was Advent of Code in F# day 7. I hope you had fun. I hope you enjoyed my struggles, and I'll see you tomorrow. Bye.